Okay, so I've got to film that all again because I filmed it upside down. So here we have the question about the stunt driver who drives a red Mustang up a ramp and off a cliff. The car leaves the ramp at a velocity of 60 meters per second at an angle of 45 degrees to the horizontal. The car begins its projectile at a height of 315 meters above the ground. How far would you put a landing surface so the driver was not injured? So what we've got going here, so I've got my cliff here, and this is 0, 0 down here. And then this is where the car takes off from. So that's actually got a coordinate of 0, 315 there. So he starts his projectile. And then down there's 0, 0, so that's where we land. So I need a landing pad there. Okay, so my initial velocity is 60 meters per second, and that's at an angle of 45 degrees. Okay, so we can get our velocity vector. So that's 60 cos of 45 degrees I plus 60 sine 45 degrees minus 9.8 t in the j direction. Okay, and then from that I want how far, so I want the position, how far away. So I need to find my position vector. So I'm going to integrate this, cos 45 degrees ti, 60 sine 45 degrees t minus 4.9 t squared j, don't forget that plus c. Okay, so this plus c, the plus c comes from when time equals 0, my height is actually 315 meters in the j direction. Okay, so therefore if that's 0, I've got no I, that's 0, that's 0 because t 0 there, so my c value is just 315j, so that's going to come into my j components there. So x of t equals 60 cos 45 degrees t in the I direction plus 60 sine 45 degrees t minus 4.9 t squared minus 315, plus 315j. Okay, now when it lands, so when it starts t equals 0, and then when it lands, the height is going to equal 0. So our height here was 315, but the height down here when it lands is 0. So I've actually got no j component at this point here. So what I can say is that this j component here, 45 degrees t, 4.9 t squared plus 315 is equal to 0. And then I can use my quadratic formula, or I can graph it, and I get t equals 13.4, and t also equals a negative number, but we don't have negative time, so it's not a solution. Okay, again, this is the time it takes, so 13.4 seconds to get to the bottom of the cliff, I guess, and we want to know how far. So if my j component is 0, my I component is going to tell me how far away. So my I component of my position vector, so that's when my j is equal to 0, and I'm going to substitute 13.4 into my I component. And that gives me an answer of 568.51 meters. Okay. So we knew our initial velocity vector because we had all the information within the question, my initial velocity, the angle. Don't forget your gravity in the j direction. I can find my position because I want to know how far you'd need to put a landing surface, so how far away I need my position, so I need to integrate. And don't forget, in this case, C is not just 0, 0. We start 315 meters above the ground, so that comes into there. And then how far away would I put? So I know that my J component will equal 0 there because I've got no height happening, and you can use your quadratic formula or graph to find your time, and then you can put that into your I component because your I component will tell you the distance away. So we got 568.51 meters.